Hi you guys, this is the first lesson in our expressions module, and during this lesson we are going to be talking about some properties of mathematics, which are basically just some rules that we follow. You may have heard about some of these properties before. I think you were introduced to these in 4th and 5th grade, I believe, but I want to review them with you. And I don't necessarily care if you know the name of the property as much as I care about you knowing what that property allows you to do. Okay, so the commutative property. Here are some examples. You can see the sum of both 8 plus 7 plus 2 and 8 plus 2 plus 7 is 17. Okay, so it doesn't matter if we add the 8 and the 7 first and then the 2, or the 8 and the 2 first and then the 7, we get 17 as our answer. Okay, the next one, the sum of both 13 and 14 and negative 3, and 3 plus negative 3 and 14 is 24. So again, doesn't matter if we add 3 and 14 first and then negative 3, or 13 and negative 3 first and then 14, our answer is still 24. Okay, now remember, sum is adding. Okay, so notice that when we're adding, it doesn't matter what order we add in. Okay, the next examples involve the product, and that means to multiply. So when you multiply 1/2 times 7 times 8, you get 28. Or if you multiply 1/2 and 8 first and then 7, you also get 28. And then the last example, the product of both 9 times negative 1/3 times 7, or negative 1/3 times 9 times 7 is negative 21. So when you add or when you multiply, it doesn't matter what order you do that in. Okay, that's basically what the commutative property tells us. So let's go ahead and look at some examples here. Number 1, we have 12 plus 4 and 4 plus 12, and the question that we're being asked is which pair of expressions are equivalent? Okay, in math, expressions are math problems that don't have equal signs. Equivalent means equal, okay, exactly equal to each other. So if we're answering which pairs of expressions are equivalent, 12 plus 4 and 4 plus 12, we know that 12 plus 4 is 16, 4 plus 12 is also 16. So we would say yes, these are equivalent. Okay, so even though the order was changed, the answer is the same in both of these cases. Okay, let's look at number 2. We have 9.8 subtract 3.4, and if we go ahead and change this subtraction to addition by doing keep, change, change, we have a positive 9.8 and a negative 3.4. So when we combine those, we're going to have a positive answer. We would have to subtract these to find out what our answer is, and it would be 6.4. Okay, let's look at the next one. In the next one, the order changed. Okay, 3.4 subtract 9.8. So if we do keep, change, change. Okay, in this case, our owing amount is more than our having amount. So we're going to have to take the 9.8, we're going to have to subtract the 3.4, and that would be 6.4. But in this case, it's negative. Okay, these two are not equivalent. So when we were doing subtraction, sorry, this should say a big fat no, not a yes. When we were doing subtraction and we changed the order, we ended up getting a different answer. Okay, so that's important to realize. Let's look at number 3. Again, subtraction. 12 subtract 4 becomes 12 plus a negative 4. 12 plus a negative 4 is 8. 4 subtract 12 becomes 4 plus a negative 12. 4 plus a negative 12 is a negative 8. And these are not equivalent. Okay. So again, when we try and change the order when we're doing subtraction, we do not get equivalent expressions. These are not equivalent. Okay, number 4. 5 times 4 is 20. 4 times 5 is 20. Okay, so when we multiply and we change the order, the expressions are equivalent. Okay, let's look at the next one. 3 times 0.9 is going to be 2.7, and 0.9 times 3 is also 2.7. So when we multiply, we can change the order, and our expressions are still equivalent. Let's look at division. 18 divided by 6. So if you take 18, you divide by 6, you get 3. Now that is different than 6 divided by 18. Because when you take 6 and you divide by 18, you're going to end up with a decimal. So I have to borrow from this, make it a 5. 10 minus 8 is 2. 18. Sorry, you guys, I need to back this up. Even teachers make mistakes sometimes. So I'm going to erase this. We're going to go ahead and start over. It's been a long, but 6 divided by 18. 6 divided by 18. We would add a decimal and a 0. And 18 fits into 6 3 times. But 3 times 18 is 54, not 48. Okay, so now we subtract. 60 minus 54 is 6. Add a 0, bring a 0 down. 3 times 18 is 54. Subtract, add a 0, bring a 0 down. We can see that this ends up being a repeating decimal. Okay, 0.33 repeating. And if we were to write 6 divided by 18 as a fraction, we can see that this fraction simplifies to 1/3, and 1/3 and 0.33 repeating are equal to each other. Okay, but 3 and 1/3, or 3 and 0.33 repeating, are not equivalent. Okay, so when this says what pattern are you noticing? The pattern is that if you change the order of adding or multiplying, the expressions are equivalent. But if you change the order when you are subtracting or dividing, the expressions are not equivalent. So what I want you to do is, in your own words, I want you to go ahead and write down what the commutative property is. Okay, so I want you to explain that in your own words. You will need to be able to do that on our next test. You'll have to be able to match the definition with the property. Okay, let's look at the next property. The word associate means partner or connect. Most often we use the words to describe groups. For example, if a person goes to Eastmount Middle School and not Indian Hills Middle School, we would say that person is associated with Eastmont Middle School. So let's look at these examples here. The sum of both 3 plus 17 plus 4 plus 16 and 3 plus 7 plus 4 plus 16 is 40. So notice in this case, there were parentheses added. So order of operations would tell us we always do the parentheses first. So if you add the 17 plus 4 first, and then add the 3 and 16, you get 40. Or if you add the 3 and the 17 together, and then the 4 and the 16 together, and then add those two together, you also still get 40. Okay, so it doesn't matter which one you choose to add first. Okay, and then the next one, the product of both 2 times 5 times 3 and 2 times 5 times 3 is 30. Okay, so again, it doesn't matter if you do 2 times 5 first and then times 3, or 5 times 3 first and then times by 2. In both cases, you get 30. Okay, now for the next part of this lesson, you are going to be given some pairs of expressions, and the operations are the same, but the constants have been associated or grouped in different ways. So you need to determine if the pairs are equivalent, and then be able to justify your answer. So go ahead and push pause on your video. I want you to push pause. I want you to do 9, 10, 11, 12, 13, 14, 15, and 16, and then push play and see if you got these correct. Okay, so on number 9, 12 plus 4 plus 6. So if we do the 12 plus 4 first, that's 16, and then 16 plus 6 is 22. Okay? Or if we do the 4 plus 6 first, and then add 12, 10 plus 12 is 22. Okay, so with addition, we would say yes. These are equivalent expressions. Okay, let's look at the next one. Number 10. So the parentheses tell us what to do first. So 12 minus 4 is 8, and then 8 minus 3 is 5. Okay, or on the next one, the parentheses say we do 4 minus 3 first, which is 1, and then 12 minus 1 is 11. Okay, so notice these are not equivalent expressions. Okay, when you're doing subtraction, you can't change who you're associating with first. Okay, let's look at number 11. 3 plus 5 is 8. 8 plus 7.4 is 15.4. Okay, or 5 plus 7.4 is 12.4. And then 12.4 plus 3 is also 15.4. Okay, so it doesn't matter if you do the 3.3 plus 5 first and then the 7.4, or if you add the 5 and the 7.4 first and then the 3, in both cases you get 15.4. Okay, so those would be equivalent. Yes. Okay, number 12. If we do 20.9 minus 8 first, because that's what the parentheses tell us, that gives us 20.1. And then if we subtract 2, that gives us 18.1. Okay, but if we change who we're associating first with, in this case, by adding the parentheses to the 8 minus 2. So if you do this first, 8 minus 2 is 6, and then 20.9 minus 6 is 14.9. So these two are not equivalent. Okay, let's look at 13. Okay, 13 is multiplication. So if you do 5 times 4 first, that's 20. 20 times 1/2 is 10. Or if you do 4 times 1/2 first, that's 2. 2 times 5 is 10. So you'd say yes, they are equivalent. Let's look at division. 18 divided by 6 is 3. 3 divided by 3 is 1. Or 6 divided by 3 is 2. And 18 divided by 2 is 9. Not equivalent. Let's look at 15. 6 times 2 is 12. 12 times 5 is 60. Or if we do 2 times 5 first, and then that would be 10. 10 times 6 is 60. Yes, equivalent. The last one, 24 divided by 12 is 2. 2 divided by 3 would be 2/3. Or 0.66 repeating. If we associate with the 12 and the 3 first, so the 12 divided by 3 would be 4. 24 divided by 4 is 6. Okay, so these two are not equivalent. So now it says, what patterns do you notice about the problems that are given? In your own words, what is the associative property? Okay, so basically when you look at these, you should see that when you are adding and multiplying, it doesn't matter where you put the parentheses. Okay, but when you are subtracting and dividing, you can't just put the parentheses wherever you want and keep the expressions equivalent. Okay, so in your own words, I want you to write down what the associative property is. Okay, and let's move on to the next property. Okay, the next one is the identity property, and the word identity has to do with sameness. We use this word when we recognize the sameness between things. For example, you might say that a Halloween costume cannot hide a person's true identity. 19 says, what do you think the identity property for addition should mean? So that means that if we have a number 5, what can we add to the 5 so that the 5 stays a 5? That's basically what the identity property for addition says. So we know that if we add a 0 to the 5, that is how the 5 stays a 5. Okay? Or if you have a 4, adding a 0 to the 4, that's how the 4 stays a 4. Or if you have a -6, adding 0 to a -6 is how the -6 stays a -6. So in your own words, what is the identity property of addition? Okay. Basically, you should say something about if you add 0 to any number, the number stays the same. On the next one, it says, what do you think the identity property for multiplication should mean? Okay, so if we're talking about the identity property for multiplication, that means what can we multiply 5 by so that it stays a 5? And that would be a 1. Okay, or what can we multiply a 4 by so that it stays a 4? That would be a 1. Or what can we multiply a -6 by so that it stays a -6? That would be a 1. Okay, so the identity property of multiplication basically says that if you multiply any number by a 1, it stays that same number. Okay, and then the next set of properties, this is a new set of properties for Math 7. The word inverse means opposite or reverse. Okay, inverse properties are basically undoing properties. So what do you think should be the additive inverse of 3? So if we wanted to cancel out a 3, what would we need to add to that to make the answer 0? So 3 plus -3 is what makes a 0. So we would say that -3 is the additive inverse of 3. Okay, so what do you think would be the additive inverse of -3 then? So if we have a -3, what would we need to add to that to cancel out the -3 or to make it a 0? And that would be a +3. So the additive inverse of -3 is a +3 because 3 added to a -3 is what makes a 0. Okay, let's look at 27. What do you think would be the multiplicative inverse of 3? So that means what is going to make 3 a 1? That's what multiplicative inverse means. So what can we multiply 3 by to make it a 1? So 3 times by 1/3, that would give us a 1. So the multiplicative inverse of 3 is 1/3. On 28, it says, what do you think would be the multiplicative inverse of 1/3? So basically, what are we going to multiply 1/3 by to get to 1? And that would be a 3. So in your own words, what is the inverse property of addition? So basically, that means what are you going to add to the number you've been given to make the sum of those two numbers 0? And then in your own words, what is the inverse property of multiplication? And that means what are you going to multiply a number by so that your answer would be a 1? So I just want to try a few of these with you. Okay, let's say you have a -4. If I ask you what the additive inverse of -4 is, you would say +4. Or if you have a 10 and I ask you what the additive inverse of 10 is, you would say -10. Or if I give you a -26.2 and I ask you what the additive inverse of this would be. So what can you add to -26.2 to make a 0? And you would say +26.2. So that is additive inverse. Multiplicative inverse is what can you multiply the number by to make a 1? So if I give you 1/2 and ask you what the multiplicative inverse of this is, you would say 2, because 2 times 1/2 is 1. Or if I give you a 4 and I ask you what the multiplicative inverse of 4 is, you would say 1/4, because 4 times 1/4 is 1. Or if I give you a 3/4 and I ask you what the multiplicative inverse is, you would say 4/3, because 4/3 multiplied by 3/4 is a 1. Okay, and then the last property we need to talk about is the multiplicative property of 0. And basically, this property says any number multiplied by 0 is 0. Okay, and let's talk about 0 for just a second. When you multiply by 0, your answer always ends up being a 0. So 5 times 0 is 0. 6 times 0 is 0. 0 times 7 is 0. 1/2 times 0 is 0. So anytime you multiply any number by 0, your answer is 0. Also, 0 divided by any number is always 0. Okay, so anytime you take a number or 0 and you divide by a number, you'll always get 0. One thing you have to remember though is if a number is divided by 0, that is called undefined. Okay, so if 0 is on the bottom of your fraction, if you're trying to take a number and divide by 0, that would be undefined. Okay, so now at this point, you are ready to start working on today's assignment. Sorry, this video ended up being really long. I hope you're able to follow along, and you are going to need these notes that you just took to be able to do your assignment. So I want you to turn to the part in your assignment that says properties, naming properties of arithmetic, homework 3.1a. And you guys are going to complete each of these 1 through 23, and then you are going to come back and check them off with me and before you move on to the next lesson. So use your notes. Feel free to come back and ask me any questions that you have, and I will see you at my desk.